Guys, hello. Okay, guys, so today we'll start the session. Sorry for the delay, sorry for all the setup. So we have spent a lot of time on the setup because I was trying to use two different screens. So this is the first time for me to use two different screens. That's why I had this problem. So I apologize for the all confusion during the session. Hopefully we'll not repeat this thing for the next session. So let's start the session and I'll just give you the brief what we're going to do. So in regression is a forecasting technique, okay, which is based on causal based models, right? So I hope you might have worked on this because if you are a supply chain analyst, definitely you might have got various opportunities to use this algorithm. So what is this causal based method? Suppose if you want to improve the sales of the product, right? So what is that factor which is going to improve the sales? What is that factor which is going to improve the sales, right? So it could be the promotions and discounts. It could be the product features, right? If you look at the power sensitive, large screen size, television, maybe a sound quality, right? So those are the features which is going to improve the sales of the television, right? Could be the season. Maybe there's a sports season is coming, summer season, right? Maybe winter season could also be responsible for the sales. People will stay a lot of time inside the home and they will prefer to watch TV. That could be also a possibility, right? So, what are the causes of the sales? What are the causes of the sales? That is what important. So, if you know the causes, and the causes are correlated with the outcome in a significant way, then we would have a chance to predict the outcomes, which is our sales, right? So we need to, so there is this causes could be correlated linearly. These causes could be correlated non-linearly. Both are possible, right? Suppose they are, if suppose they are, suppose they have a linear correlation. I will not go into what is correlation and how to measure correlation and all these things. It's a different topic. If there the linear correlation, then I say we have to predict the forecast. This y hat is my forecast. So y hat is equal to, there is a constant called alpha, there is a coefficient called beta 1, and our factor 1. Coefficient 2, then factor 2. Coefficient 3, and factor 3. So how to measure these coefficients and everything using a formula, that's a different study. We'll not go into that. We'll be using a tool called data analysis tool from the Excel to measure this. Compute beta 1, beta 2, and beta 3. Right? We're going to use a tool called data analysis in Excel to measure this. Or otherwise, we can also measure manually these things, but we will not go into manual calculation because that's not the main objective of this particular talk. Okay. Now the point is how to decide this beta 1, beta 2, and beta 3. Right. So to decide beta 1, beta 2, and beta 3, we need to first measure our error. So y minus y hat, right? Y minus y hat is called error, where y is our sales and y hat is our forecast. Okay. So, so since this error could be positive as well as negative, we will be using a different approach to take this error. And that approach is called error square. That will be y minus y hat the whole square. Okay. So since this could be positive or negative, if the y is if the sales is high, forecast is low, y minus y hat is positive. If if the sales is low and the forecast is high, then we get negative. And if the sales is low, the sales is high and forecast is low, then we get a positive value. So that is going to create some kind of cancellation effect. All positive values and negative values will be cancelled in the when we do the measurements. So that's why we're going to use a approach. We're going to approach different approach to calculate our error, and that is y minus y hat the whole square. Okay. Now what we want is, and what we want is y minus y hat, right? We're going to plot this y minus y hat or y minus y hat the whole square, right? What we want is that we want the error to not display any specific patterns in the data, in any specific patterns. Suppose a error can display a trend pattern. If you see error trend pattern means suppose, so this if my y-axis is error, okay, and x-axis is could be my one of the factor, okay, and we draw a scatter plot. Okay, we draw a scatter plot. So when you draw a scatter plot, what happens is, the distribution can be like this. So what we see, there is a pattern here. So we don't want such kind of patterns in the error. You can also see another patterns like this. We could also see a pattern like this. We could also see a pattern like this, right? Or we could see a mix of patterns like this. So we don't want any kind of patterns like this, patterns in the error. So we do not want patterns within the error. That is what one of the major objective from the forecasting. So if you want to say sales is equal to forecast plus error or plus minus error. So forecast is our pattern and plus minus error is no pattern, non-pattern error, non-pattern. So if I write this in a more simple form, a more formal form, so pattern plus minus randomness. So what we are saying is that effectively, we don't want any kind of pattern in the error. We want all the pattern to be in the forecast model. That is not possible realistically, but we want to have as minimal patterns available in the error. So these are objective of the forecast. So if you want to have a very high precision forecast, you need to extract all the patterns which is present in the error, right? That is a major objective. So so we have just discussed that the error should not have any kind of patterns like seasonality or anything. We also, if say that, suppose we have a data like this, our error is like this. Okay, so what we see in this case, some kind in some places, suppose this is my average of the data. For example, this is my average of the data. Okay, so what I see over here is there is a unequal unequal gaps at every point. So the gap between the average line and the peak or the trough of the graph is not equidistant. So this is called unequal variance. If I draw this plot even better, then right. So we see there is unequal variance between the average and the some in some way in some places. If this is my center of the line, so if you look at the gaps are not uniform. The gaps are not uniform. So if we have such kind of data where the gaps between the average and the peak and the trough, this is peak, this is our trough. Okay, this is our peak and this is our trough. So the gap between the peak and the trough at each and every point is not same, then we say we have unequal variance. Okay, so we don't want error to have unequal variance, right? So this is another thing what we are looking for in the error. We also want data to have equal mean. We also want error to have equal mean. Okay. So when we combine all these parameters like equal mean across all the periods, equal variance across all the periods, and data showing no patterns. like trend and seasonality. Then we call the dead error as a random series or a white noise series. This is our objective when we do the forecasting. We need to achieve an error having a white noise series. So this is a major objective of white noise series. So this I have to write like this. Major objective of error forecasting, where we need to achieve a random error series. So this is what we are trying to achieve. How to achieve statistically? That's another. How to achieve it statistically? There are many approaches out there. So I'll discuss the approaches one by one. So there is a very interesting forecasting model called ARIMA or SARIMA, right? Which takes care of three aspects. So y hat is equal to alpha plus AR model plus seasonal AR model minus AR into seasonal AR model plus MA model plus seasonal MA model if it is present plus MA into SMA interaction effect model. So this is one of the very good model which takes care of the randomness within the non-randomness or randomness within the error. So how that it is taken care is the MA model which we're talking about. MA model which we're talking about, it takes care of the patterns present in the error. So this is one of the approach. So the MA model is written like this: alpha plus gamma 1 into lag 1 of error or gamma 2 lag 2 of error plus et, right? So this is we're taking the errors from we're taking the lags of the error. What is lag and all those things we cannot discuss right now. So the lags of the error we are taking and putting into the overall model. So this is where we take the MA process, recursive moving average. We call this recursive moving average process. So we take the errors into the picture and we try to, if any randomness is present, any kind of pattern, sorry, any kind of pattern is present, even if the pattern is not present, but any kind of pattern is present, we'll be trying to extract out that pattern through this process. This is approach one. Approach number two. In the approach number two, what we're going to do is that we are doing some forecast and we're getting an error, right? Plus minus error. So what we're going to do, this is our forecast one, and we're going to apply a forecasting model on error also. So we're going to get a forecast number two plus minus error number 2. Okay. If error number 2 is a random series, we'll stop here. So our new forecast model is forecast 1 plus minus forecast 2 plus minus error 2. So this we are going to continue until unless we are going to achieve the error as a random series. This is approach number 2. We go to approach number 3. And this is, we're going to apply a approach called weighted least square regression. We also call WLS. And this is we're going to apply on the regression technique. If your original forecast model is regression, then we're going to apply this weighted least square regression on the regression technique. So what we do in this case is we do initial forecast. The initial forecast is suppose alpha plus beta 1 factor 1 plus beta 2 factor 2 plus beta 3 factor 3. Okay, this is our initial forecast. Now what we're going to do is that we are going to calculate our errors y minus y hat. Okay, we are also going to calculate our error square, that is y minus y hat the whole square. We're going to build scatter plots y minus y hat the whole square with versus x1, y minus y hat versus x2, y minus y hat the whole square versus x3. We're going to build some scatter plots to understand which particular input or which particular factor, which particular factor is responsible for unequal variance. We can also build a model between x1 and y minus y hat the whole square. X1 versus, and we can build a regression equation. We can also build a regression equation versus x2 versus y minus y hat the whole square. We can also build a regression equation y3 versus y minus y hat the whole square. So we may have to build 3 regression equations. Scatter plot can give us a very good understanding about which particular variable is responsible for the unequal variance in the error square. Okay, that can give us a very good visibility. If that is not sufficient for you, you can also build a regression equation between x1 y1 minus y hat the whole square, x2 y1 minus y hat the whole square, and x3 y hat minus y hat the whole square. Okay, so where y minus y hat square is your dependent variable, and x1 or x2 or x3 as a independent variable. So we are going to get three equations here. Y minus so y1 minus y hat square. We get 3 predicted values, one with x1, one with x2, and one with x3. What we do, the predicted values which you get y1 minus y hat square with respect to x1, we divide this y1 minus y hat the whole square. We divide this to, we call this as a weightage. Similarly, we're going to do something y hat the whole square again with the and with this is with respect to x2. So this is one y1 minus y hat whole square with respect to x2 with respect to x1. Similarly, we're going to build another equation x3 minus xy. So y1 is minus we get a forecasted equation here. Again, we are going to divide y1 minus y hat the whole square with respect to x3. So we are getting three. So we are going to build weightages. So this is with respect to x1 with weightage 1 with respect to x1, weightage 2 with respect to x2, weightage 3 with respect to x3. Okay. So we are going to build three weightages: weightage 1, weightage 2, weightage 3 with respect to x1, x2, and x3. Okay. And what is weightage? Weightage is just the reciprocal of the predicted equation with respect to x1. So once we get this weightage, then what we're going to do is that we're going to divide our entire model. Suppose we had y, or the previous y, which is a dependent variable, which was sales. The previous x1, x2, x3, which are factor 1, factor 2, factor 3, right? So what we're going to do, we're going to divide, and we also have the previous error. We're going to divide the entire model by this weightage, y by weightage, x by weightage, x2 by weightage, x3 by weightage, and error by weightage. We'll try this with all the three options. So y by y2, w2, x1 by w2, x2 by w2, x3 by w2, e by w2. And the last one is y by w3, the third one, x1 by w3, x2 by w3, x3 by w3, and e by w3. So we're going to we're going to build three different equations where you're going to divide the weightages coming from the first weightage, w1 is what? This one, where we are taking the error value, we're taking the error prediction coming from when x1 was a independent variable and y minus y square is the dependent variable. In this case, the x2 is the independent variable and y minus y square is the dependent variable. In the third case, the x3 is the independent variable and y minus y hat the whole square is our dependent variable. And the first case, x1 is the independent variable and y minus y hat the whole square is a dependent variable, right? So what the predicted equation which we get, that what we're going to do, we're going to divide that. This is a predicted value. This is a predicted value. Okay, we divide this, and this once we divide this, we get our weightage 1, weightage 2, and weightage 3. And then what we're going to do once we get the weightages, then what we do, we're going to divide the entire previous model by those weightages. So why we divide these weightages? Because the variance is the variance is moving up or down with respect to x1 or x2 or x3, either one of them, or maybe two of them. Okay, x1, x2, or x3. So the variance, which is error square, is moving up when the x1 grows. We build a scatter plot, right? To understand if x1 grows, what happens to the y minus y hat the whole square? If x2 grows, what happens to the y minus y hat the whole square? It may be like constant like this. If x3 grows, what happens to y minus y hat the whole square? Again, this is a constant. If suppose in this two cases is constant, in this case it is not constant, then our y minus y hat square is varying with respect to x1, right? So suppose our sigma square is into x1. Our variance is a factor of sigma square into x1. So what I'm going to do, I'm going to divide this x, the factor of x1, both sides. We get variance, sigma square. And this sigma square, once we get, means this is constant. So we need to understand whether x1 is the y1, y minus y hat square is changing with respect to x1 or x2 or x3, right? If it is x1, then we're going to use x1 as the weightages derived from the equation where we had y minus y hat square as the independent variable and x1 as the independent variable. That is what we're going to use. And we're going to divide our predicted y minus y square, the whole square, by 1. So then that becomes 1 by y minus y hat the whole square. That's the weightage. And that weightage we're going to divide the entire equation. The entire equation we're going to divide it by a weightage 1. So y by w1 is our new dependent variable. X1 by w1 is our new independent variable. X2 by w2, so w1 is our new independent variable, and x3 by w3 is our new independent variable, and error by w3 is our new independent variable. So this is the third approach. Once we use this approach, we are going to achieve a forecast model which will have a equal variance, equal mean, and we may also see the data will be devoid of any kind of patterns. So let's see how we can achieve this in our Excel model. Okay, I'm sharing my screen. So let's say this is the data which we have. Now I'm going to use a regression technique here. For that, I'm going to compute. So I'm going to compute I'm going to compute a forecast. I'm using one single factor. So this is going to be forecast dot linear is a forecasting method which is used to calculate a linear regression. So this is our factor, our independent variable, and this is our dependent variable, and this is our again independent variable which you're going to take. So now close the bracket. Now you see the forecast is coming 5,334, and our data sales is 7,131. So I'm going to drag this formula, and I'm going to calculate the error now. So error is forecast minus sales. Now I'm going to calculate the square error. So we have to do some test for the we have to do some tests that also we'll do. That is that is a study of equal variance or unequal variance test is there. That's called Bruce Pagan test, White test. Okay, those things also we can do, but I won't include those things over here at this moment. So now we got square error. Okay, so we have to complete Bruce Pagan test to understand whether our error is a white noise series or not a white noise. Sorry, our error is having equal variance or unequal variance. For that, we need to conduct a Bruce Pagan test. okay, or a weight test. I'm not conducting those tests over here. I'm directly going into the calculating the weights. For first need to have to do is again I have to use a new forecast equation. So the new forecast equation is forecast.linear. I'm going to use my x again this timeline, but this time a y will change. The y is square error, and my x is timeline. Okay, so now we got y minus y square, the predicted one, right? Now we have to calculate weights. So what is the weight? Weight is 1 divided by, we can do two ways. We can either take square root of this, or we can take the weights as 1 divided by the forecast. Okay, so now what we're going to do, I'm going to get new data points. So this is going to become 1 divided by the weight. This will be your new sales. This is a new timeline. So your new sales will be 7131 divided by weight. And our new error, I'll build a plot for the new errors. And also build a plot for the old error. Still, we have not been able to reduce our error, reduce the unequal variance in the error. By looking at this chart, this suggests that we have not been able to eliminate. So what I'm going to do, I'm going to take another method. This is my error divided by the new weight. So you're not able to see any kind of unequal variance elimination from this model till, right? We have done some work, but it is not been, we have not been able to achieve that. So this is the process where we can actually eliminate unequal variances from the model. So we're going to continue some more exercises in the next live podcast. Continues. We have to do some more work on this. So we're going to continue that in the next podcast. So if you have any questions, meanwhile you can post on my social media channel, or you can also connect with me on my email ID, which is, if you can see the email ID is being displayed on the screen. So you can also connect with me on the email ID, and I will be able to reply. Or you can also WhatsApp me. The number is also being displayed on the screen. The WhatsApp number. You can also connect with me on the WhatsApp number. So we'll be continuing this series of achieving white noise error series. Maybe in the next 3 or 4 podcasts or live talks will be focused on this particular topic. So don't consider this is a last session on this. We'll be doing some more sessions on this. so that you will be able to understand how to achieve a white noise error series. Maybe in the next session, we also will do the Bruce Pagan test and the white test on the data, on the error data, to understand whether we have equal variance or unequal variance. But also we will see. So be connected with me on this particular podcast. Be in touch with me on this podcast, and keep on posting, keep on watching our live sessions on the social media channels: Facebook, LinkedIn, YouTube, Instagram, and all. So please keep on watching. Please keep subscribing. Please share our links to your friends so that they can also join and get the benefits out of this particular live podcast, which is completely based on supply chain analytics. So you'll be getting a lot of exposure on supply chain analytics if you're able to join these particular live sessions. And so please be with our social media channels, and please also visit our website. So I'll share you my details of the website so that you can go through the website once. Guys, I'm sharing my website details once again. So my website is www.maternal.tech. You will be able to see a lot of courses over here, a lot of consulting programs which you can do with the clients. Also, you can visit our social media channels from the website. Okay, the links are given as an icon on the top of the screen, so you can go from there. And if you want to connect with me personally, you can email me at krish naidu @maternal.tech, or you can also WhatsApp me at +91 89 77 924 637. Right. So we are going to have another 3 to 4 live podcasts on creating a error, creating a error, creating an error with white noise series. This is a very, very important thing. If you want to control your forecast, you have to control your error. That's the most important. If you want to control your forecast, you have to control your error. If you are able to control your error, you are going to control your forecast. So it's just forecast is just not about the forecasting models on the sales data, but forecast we have to also understand many things about the error. Okay. So if you want to have join trading programs, if you want to have any kind of consulting assignments, please connect with me on the email ID or the WhatsApp. I'll be able to definitely be able to help you. Okay, guys, so I'll take the leave now, and we'll be connecting again with our new podcast on this series. Till the time, I'll take leave. Take care and have a nice day.